So, hello everyone. My name is Raphaël Bizos, and today I would like to talk about automatic aggregations. Before we jump in, let me shortly present myself. So I'm a SRE in the team in charge of observability, whatever that means, in Criteo, which is an ad tech company. So far, I've done many things, such as migrating Graphite to Prometheus and introducing OpenTelemetry. So initially tracing and now a little bit in metrics. I would like also to start to give a bit of context on my team and give a few numbers that will be helpful to understand a bit where we are coming from. So my team manages the metrics, logs, and tracing infrastructure at Criteo, as well as we provide some SDKs so that the team can send us their telemetry data. Metrics-wise, we ingest around 15 million data points per second, which is roughly a billion active series. This is done by 1,500 Prometheus, more or less, worldwide. And those time series are aggregated to 100 millions, then stored for 3 months and downsample for a year. Disclaimer, we're going to talk about that. And we have many users, so more than 1,000. Those are SREs, developers, data scientists, and researchers. So our objectives are quite simple. The first one is to have a reliable platform, meaning that we don't want our users to ask themselves, is the metric platform having a trouble, or my alert is firing for a good reason? We want metric to be fast as well, so that at night during on-call, they don't have to wait for a minute every time they change a variable in Grafana. On the opposite, we want to have our users to have a very simple experience possible, so that they don't need to think too much in the internal of the metric platform. We want them to write metrics in their code and query metrics in Grafana without having to go deeper within the internals. Internally, we call that the zero-effort observability. And of course, we have the cost. If we had unlimited money, that would matter much less. So as a first glimpse, those three objectives looks a little bit disjoint. So maybe we want to throw extra hardware so that the stack is very stable, but that will cost money, obviously. Maybe your user want to store every single metric for a limited amount of time. Again, that looks maybe a good idea in the perspective, but in terms of cost, and maybe in infra, it might not be. So what I want to share today is our approach to find the middle ground between all those three things, which we find with automatic aggregations. So I would like to do it by presenting how it evolved over time, because it didn't start as mature as it is today. So in the beginning, we actually were using Graphite. I'm not going to talk too long about that. We're not at GraphiteCon, right? So we had cardinality issue at this moment, and we couldn't query more than 10,000 metrics at once. So it was a big problem because some teams couldn't actually query what they needed to have their dashboards and alerts. So actually my predecessors in the team introduced some Graphite aggregations. The way it works is that if your metric matches this pattern, so with this counter sum in the middle, it will get aggregated to a single metric. So here we start from 1,000 and we are reduced to one metric. So how you would do that in Prometheus? The first answer would be to write recording rules, right? But remember, we have hundreds, if not 1,000 users. We have millions of different metrics. If we had to write recording rules for most of those metrics, it would start to pile up a little bit, and we would need to maintain all of that. Right? So that's why we turned into some kind of automatic aggregations. So that was named the oversea model. Let me present that quickly. So in this case, we do have Prometheus still. Prometheus will scrape metrics on application with a special oversea format, which I will present on the next slide. It will then aggregate those metrics and send them to the rest of Graphite for remote storage. Now, this oversea model is a bit weird. So the metric name is actually the metric type that will control how the metric is going to be aggregated. And then something that I'm sure a Prometheus team wanted us to do is on the name we put the metric path, because at this moment we couldn't put any dots in the metric names, so we had to put it here. So we mentioned that the type control how the metric is going to be aggregated. So we know a counter, we apply rate then sum. For gauge, we do percentiles, average, min, max, sum, and count. And then for histogram, we do percentiles and rate and sum. So let me give you a short example on how that works for a counter. So we have a set of metrics here with, again, 1,000 instances, which is a counter exposing a HTTP request total amount. Then the first step is to aggregate it without the instance. So we get a single metrics out of that. And then we store that to Graphite. A question that you might ask is, why do we remove this instance dimension? So first things first, it's common to every metrics. So when Prometheus scrapes your endpoint, it will add job and instance labels. So we don't have to have any specifics on all of the metrics that your service exposes. It just reduces every metrics. It's usually a big source of churn, of cardinality, a bit over my head. So meaning that you usually have several instances. Of course, the more instances you have, the more cardinality this reduces. So if you have 1 or 2 instances, it's not really useful, but if you have hundreds or even thousands of instances, then it reduces drastically the amount of metrics. Then it's a source of churn. So churn is kind of the renewal of the metric over time. So it's cardinality, but on the time dimension. So usually instances are short-lived. For instance, pods UIDs. Whenever you deploy a new version, then you have a new pod UID. And then all of your metrics change. So if you remove that, you remove a big source of churn. And then a bold claim I have is that usually instance is not really needed, except if you want to troubleshoot for this specific instance. Let me show you a bit why I think that. So here I show the memory usage for a service of 100 instances. So you can see more actually than 100 time series here because you have the churn of the new instances starting. It's very colorful, nice, but not really easy to read. And it's also quite slow to query because you query hundreds of metrics. On the other side, you only have aggregated versions, so you have percentile, so mean, max, median, and 90p. One thing is it's as easy to read, if not better, but also you only query 4 metrics for the whole period instead of more than 100. And the more, the biggest your time window you use, the more impactful this is going to be. So I have a short video here where I show the same metric, one being aggregated at query time, and one with pre-aggregations. So this is roughly 1,000 instances getting aggregated, and I will query 30 days, then 90 days. So the pre-aggregation is instant. Then for the 30 days, it kind of works. Then we try to query 90 days. It is instant again with pre-aggregation. And then at query time, we actually time out. Note that when you are waiting for your metrics, not all of your backend is idle and waiting for you. It's actually consuming resources, probably CPU, to query all of those metrics. And in here, it's for nothing because it's actually timed out. And to give you an order of magnitude for the biggest application we have, we'll reduce totally 120 million down to less than 4 million metrics. So it actually reduces quite effectively. So this is the first, let's say, iteration, really fully automatic aggregation that we have. So every metrics exposed by the service with this pattern are aggregated without any requirement of the name. And absolutely 0 recording rules have been written by your users. And actually, the recording rules we are using have been the same since years. So we don't take a lot of maintenance. Though it kind of requires this weird specific data model and exposition format, which is unique to our SDKs, and kind of, I suppose, an anti-pattern, to use the name in a special label. And also something that we still have is this graphite shadow over us. Now, let's move closer to the present, in which we trade a graphite backend with Victoria metrics. So this will actually work on any Prometheus-compatible backend, so Mimir, Thanos, Cortex, We chose Victoria Metrics for different reasons. One of them is that it supports graphite, so it helped for the migration. So Prometheus-wise, it will work exactly the same way. It scrapes, aggregates. What changes happens afterwards. So now we have different cluster on which we send data. So on the top, we have the core cluster on which we send aggregated data for 3 months and then for a year. We actually have two clusters that have active passive in different regions so that we can switch from one or the other if we have a big maintenance or if we have an incident going. And those clusters are used for alerts and dashboards. On the bottom, we have what we call the instance metric cluster on which we send raw metrics or unaggregated metrics, and we store them for 7 days. Those 7 days come from the fact that we have a 7-day release policy, and so we know that instances shouldn't live more than that. So we don't store short-lived metric for a year when we really need them for maybe 7 days or maybe a little bit less. So if we stored all of those instance metric on the core cluster, it would cost much more because we would need to have a much bigger cluster. But the way it's really interesting and why it's so important in our reliability has something to do with churn. So here, what I show is what happens when we deploy a big application. So you can see a big spike in the instance metric cluster on which we query new metrics. We create new metrics, maybe 150 new metrics, 1,000, 100 every second. And on the core cluster, not only it's much shorter in time, but also much shorter in magnitude. If I show that in maybe something a bit more absolute, in the instance metric cluster, the insertion are about 6% slow. 6% of the insert are slow for half an hour, when on the core cluster, it never goes above 1.1. So this is very important because we know that usually trouble comes when we apply change. So when there is a new version that rolls out, that's when the team really needs to monitor their services, right? And if you deploy a new version and it affects the metrics cluster, then how can you trust your alerts? How can you trust the dashboard? Maybe something fires. And how can your users can actually deploy new versions consistently? Also, if you want to do a continuous delivery, then how can you make automated decision on something that is not reliable? And that worked quite well for us because we had close to 100% availability, like zero downtime for like 6 months, and our response time isn't affected by deployments. Now, the last month, we had to deal with scraping a new service that exposes hundreds of millions of metrics, which was challenging even with that model, a bit expensive. So we decided to give a shot to something that we heard last year at PromCon about streaming aggregations. So you might have noticed that the way we use Prometheus, it's kind of like an agent. So we don't really leverage the TSDB. Like we scrape and we remote write. We don't really retain the data for some time. The thing is, we would like to use Prometheus agent. The problem is it doesn't support a recording rule, so we can't really do the same thing as we did. VM agents come with those streaming aggregation that are kind of like recording rules, but only limited to aggregations. So it's a good way to reduce the amount of metrics. So we decided to give a shot, and we can see that just by the fact that we don't have this TSDB, it reduces a little bit of the CPU, but mostly it reduces a lot the memory usage. So those numbers should be taken with a bit of caution. Our benchmark was a bit naive. We just throw the two systems with the same metrics and the same aggregations. It might be affected by the kind of aggregation that you make. And also we can optimize a little bit Prometheus. Like we can reduce the head chunk size to keep it and reduce it a bit. Though we were super happy to use that because we were able to roll it out for a fraction of the price. Just note that it works if you have this kind of agent mode. If you need any recording rule, alerts, or federation, you should do something else. Now, I would like to speak a little bit on what we are currently working on, because we really want to get rid of this graphite format, and because it's useful, but it means its end, right? So we want to build Prometheus native automatic aggregations. So we want to be compatible with open metric formats. especially the 2.0 that was just presented. We want to be compatible with OpenTelemetry semantic conventions, because we don't want to block ourselves not using it. And we know that those two formats are not the same, so we want to have something generic enough. And just for the sake of it, we want to be compatible with native histograms because our user would like it a lot. And we were very lucky because more or less when we started working on it, Prometheus team released this feature flag allowing to have type and unit labels in Prometheus. So we decided to give it a shot and to make a proof of concept out of it. The way it works is very simple. So I didn't put an instance here because it would be a bit dense on the screen, but pretend that there is an instance here. So I chose OpenTelemetry from the semantic conventions for HTTP so that we show that it works for that. So the first step is actually we store the metric name into a temporary label to not losing it when we do the recording rule. Now the second step is we do the same thing, so we do an aggregation without the instance. In this case, it's a histogram, so we do rate sum, and then histogram quantile. And we keep a suffix and a prefix to reassemble the final aggregation at the end. And then the last step is actually done with the remote write relabel configs, on which we reassemble all those parts of those metric name, and we only keep the labels that we need. So since the type is actually provided by Prometheus now, it's compatible with OpenMetrics, it's compatible with OpenTelemetry protocol, it's compatible with Prometheus protobuf. So we're super happy to start using that. And it's, as such, compatible with native histograms. So we'll continue working on that and trying to release something in production as soon as possible. One thing is on the example I show, we do the reassembly of the final metric with the remote write. So if you do federation, you need to apply the same labeling, otherwise you'll get the in-between format. Now with automatic aggregation, that started with kind of a technical limitation. We decided to use that to build our stack and to build how we approach metrics. The first thing is that it allowed to have a good retention for our metrics with absolutely zero effort from our users, which matches maybe 80–90% of the use cases. Then we decided to use that further and protect ourselves from a surge of new metrics during deployments. And as such, we have a very stable platform. And since we decide to keep only the metrics that are stable over time, so we don't keep short-lived metrics, we don't pay for them for keeping them very long. So, thank you for your attention. Yeah.
Thank you. Any questions? Anyone? Anyone? Yell out if I don't see you.
Thank you so much for the presentation. Just maybe a question you mentioned regarding the alerts. They are being executed on the core cluster, right? And
yes.
Where the retention slightly bigger than on the another one, and why not on the cluster with the 7 days of retention?
So that's a good question. The reason is that if you do alerts on the instance metric cluster, you query a lot of metrics, and your alerts is dependent on if there is or not a deployment. So we say that you should query alerts for aggregated metrics on which we should query much less metrics. This is actually done with a header that Grafana provides on the alerts, so you know that the query comes from alerts or a dashboard. So a dashboard works for the 7 days, obviously.
Okay, thanks.
Any others? Nope. All right. Thank you so much.
Thank you.